Hi everyone. So in this video, we're going to start talking about the idea of the domain of a function. So this is something that we're going to continue to discuss in the next few videos. Basically, in order to get really technical with finding the domain of a function, we're going to have to learn some new notation. So that we're going to cover in the next video. We're going to learn about interval notation and set notation in the next video. So this video is more of an introduction and sort of getting the intuition down for what it means to find the domain of a function. Okay, so what is the domain of a function? Well, the domain of a function basically refers to all of the numbers that you are able to plug into that function. So the domain of a function is the set of all possible inputs of the function. So all of the numbers that you are able to plug into that function. So the domain for the types of functions we're going to look at is going to include all real numbers for which the function is defined. So basically, when we're looking at domain, we're kind of focusing on, what numbers give us something that is defined. Those numbers are in the domain. And what numbers give us something that is undefined, and those numbers will not be in the domain. So by the way, there's also another word that you might have seen before, which is the range of a function. So I'm going to define that. We're not going to be focusing on that for now. We'll get to that when we talk about graphs of functions, because basically it's just a little easier to talk about range of functions with graphs. But I'll just write that down for so you kind of know what it is. So the range of a function, so if the domain is the set of all inputs, the range is the set of all possible outputs. So all possible outputs of the function. So I'll just write down here more on this later, because as I said in this video, as well as the next few videos, we'll be focusing more on the domain. Okay. So for the majority of this video, we're going to be talking about finding the domain of functions defined by formulas. But I first just want to quickly do an example of a function defined by a table, just because that is kind of an interesting, slightly different example. Actually, let me label it that way. So functions described by tables. So there's one kind of important distinction that I need to make here, which is there's a difference between, so let me actually first write down this function, and I think once I have it written down, I can explain what I'm about to say. So this is a function defined by a table. So what I want to say is that there's a difference between a function that is described or defined by a table and making a table for a function. So if you have a function that's described by a formula, so I'm just going to kind of write down a side example for a second, unrelated, like if you have a function, f of x is equal to x squared minus 2 or something, you can make a table for that function, right? You can pick out some values and make a table. That's not what we're talking about here. What we're talking about, if you have a function that is defined or described by a table, that means that the information on that table is the only information you know about that function. So whatever is on this table, that is all we can say about this function. So what would the domain of this function be? Well, remember we said that the domain is all of the possible inputs for our function. And so in this case, the possible inputs are the numbers 1, 3, and 4. So the domain of this function is basically just the numbers, or not basically, it is just the numbers 1, 3, and 4. Those are the only numbers that we're allowed to plug into this function. So just to kind of drive that point home, if we try to plug in 1, we get -1, right? If we try to plug in 3, according to this table, we get -3. If we try to plug in 4, according to this table, we get -4. So all of those numbers, 1, 3, and 4, are numbers that we are allowed to plug into this function. So what if we tried a different number? So let's say I tried to say f of 2. You might guess, based on how this table goes, you might say, oh, well, it seems like f of 2 is going to be -2. And that's probably like a good guess, but if this table is the only information given, you cannot come to that conclusion. You can't just say, well, it kind of looks like based on the pattern that f of 2 is -2. This table is the only information we have. And so 2 is not in the domain. So if you were to try to evaluate f of 2, your answer would actually be undefined because there is no information about what f of 2 is. So again, we just don't deal with functions defined by tables as much as with formulas, but I just wanted to kind of mention this because it's an interesting kind of counterexample that when you're dealing with tables, you're really just dealing with a few specific numbers as your inputs. Whereas, as we'll see in the next few examples, when we're dealing with functions described by formulas, our domains are going to include way more numbers. Okay, so now we're going to be looking at functions described by formulas. Okay, so in order to kind of point us in the right direction with finding the domain of functions described by formulas, we basically need to know what are the things that can go wrong in a function that can make it undefined, right? Because those are the numbers that are going to be not in the domain. So I'm going to write that down. What can make a function undefined? So like just in terms of numbers, like what can you do with numbers that results in, does not exist? Or if you were to type it into your calculator, you'd get an error. So maybe pause it and think about that for a second. Think about what are the things that you kind of know that you're not allowed to do in math. So the first one we're going to see is dividing by 0. So if you try to divide a number by 0, you will get a result that is undefined. So for example, if I tried to say 2 divided by 0, that would be undefined. It does not exist. You would get an error if you typed it into your calculator. And we'll see how that plays out with finding the domain in a few moments. One thing I just want to mention is that it is okay to do 0 divided by a number. This is something that a lot of students kind of mix up. So kind of by the way, side note, it is totally fine to divide 0, let me write it as a word here, 0 by a number, right? Like the reverse. So if you take 0 divided by 2 instead of 2 divided by 0, well, that's just equal to 0. So 0 divided by a number is 0. The issue is when you try to divide by 0. And if you're trying to understand why is that, like what's the deal with that? Basically, if you think about it, dividing is like asking how many times a number fits into another number, right? So for example, if you're doing 6 divided by 2, just write this down, I'll erase it afterwards because it's not super relevant, but 6 divided by 2 is equal to 3. So why is that? Well, it's because you can fit 3 copies of 2 into 6, right? If you have 6, you can think of 6 as being made up as 3 collections of 2. So if you're taking a number and dividing it by 0, so say like 2 divided by 0, that's basically asking you how many times can you fit 0 into 2? And that question just doesn't really make sense. So that's why it's undefined. Whereas if you're taking 0 and dividing it by a number, that's asking you how many times can you fit 2 into 0? And there the answer is just, well, none, right? 0 doesn't contain anything, so 2 goes into 0 no times. Whereas the idea of fitting 0 into another number, that's a little bit muddier. And that's something that, by the way, you'll learn a little bit more about when you get into calculus by using this thing called limits, but that's a total side note. And also 0 over 0 is also defined. So if you're doing basically any time 0 is in the denominator, you get a result that's undefined. Okay, so what's the other situation that will lead you to an error or something that's undefined? Well, taking the square root of a negative number. So this is something that, depending on what math classes you've taken before, you might have actually learned a way to take a square root of a negative number. So for example, let's say you have square root of -4. You might have learned about something called imaginary numbers, and you might remember that actually you can rewrite this as 2i. In this class, for now, later we'll actually talk a little bit about imaginary numbers, but right now we're only talking about real numbers in this class. And if you don't know what I'm talking about, just don't worry about it for now. But basically, in this class, for now, if you're taking the square root of a negative number, that is always going to be undefined because it's not a real number. So why is that? Well, think about what a square root means, right? So if you take the square root of, let's say, like 4, that's equal to 2. So why is that? That's because 2 squared is equal to 4, right? So square root is actually kind of asking you to work backwards. So if you're taking the square root of a negative number, well, there's no, anytime you take a number and square it, you get something positive, right? So it just doesn't make sense to take the square root of a negative number. Okay, so let's look at how this will actually play out in terms of finding the domain. So I want to look at a first example here. Actually, I'll go to another page. So let's try to describe the domain. So when I say describe, we're going to sort of say in words what is and what is not in the domain of this function. So our function is going to be f of x is equal to x squared over x minus 5. So we want to think about, what numbers will make this undefined. I think that's kind of the best place to start. So as we just saw on the previous page, you run into a problem when you have a 0 in the denominator, right? And so we need to figure out what number would make the denominator of this 0. So we can say that f of x will be undefined when its denominator is 0, right? That's really what will mess this up. And I'm going to change colors here just to give us some variety. So what would make the denominator 0? Well, if we were to plug in 5, that would give us 0 in the denominator, right? Because 5 minus 5 is 0. So this will occur when x is equal to 5. So another way of saying that is that f of 5 is equal to 5 squared, so that's 25 over 0, which is undefined. I might go off the page slightly here. And so what does that tell us about the domain? So remember, the domain is supposed to be all the numbers that you can plug into this function. So the only number that's going to give us an issue here is 5, right? Because when we plug in 5, that's what will make the denominator 0. So therefore, the domain is all real numbers except for 5. That's the only number that's going to mess this up. You might think 0 could be an issue, right? But what happens if you plug in 0? Well, if you plug in 0, you would get a 0 in the numerator and you'd get -5 in the denominator. And that's fine. That's just equal to 0. 0 divided by something is okay. The only thing we're looking out for is having the denominator equal to 0. Okay, let's do another one. So we'll do another one that is kind of along the same lines as this one, and then we'll look at an example involving square roots, or actually a few examples involving square roots. So maybe I'll name this one g of x. Let's look at the function g of x. Actually, let me write this out. So we're going to describe the domain of g of x is equal to x minus 2 divided by 3x minus 9. So again, same kind of thing as the last one, right? So the domain is going to consist of all the numbers so that this function is defined. So what's going to make this undefined? Well, when the denominator is 0. So g of x is undefined when its denominator is 0. And so this one maybe is a little trickier to see. Like in the one above, I think you could just kind of look at this denominator and say, oh, well, if I plug in 5, it makes it 0. And you can do the same thing here, right? You might be able to see that, okay, if x is equal to 3, that's what's going to give me 3 times 3 is 9 minus 9 is 0. But let's say that you, for whatever reason, just weren't seeing that. How could you really figure out what number makes the denominator 0? Well, you could take the denominator and set it equal to 0, right? That's one way to figure out where the denominator is 0. So to figure out, let me say it this way, for which x value, for which this occurs, what we can do is we can set the denominator equal to 0. And so that's going to tell us that 3x is equal to 9, and that will tell us that x is equal to 3. And so that tells us that 3 is the number that makes the denominator 0. And that's going to be, therefore, the only number that is not in the domain of this function. So the domain is all real numbers except 3. That's the only number that is going to kind of mess up this function. So as I mentioned, in the next video, we'll learn some new notation that will allow us to express these answers on these two questions in what's called interval notation. For now, I really just want you to be able to say it in words. Because if you say it in words, then to me that means you kind of understand what's going on, and we can get into the more technical version of it a little later. Okay, so next one I want to look at is the function h of x is equal to the square root of x minus 3. So I want to do things a little bit differently on this. So with these past two examples, there's really only one number that made these undefined, right? So with square root functions, it's going to be more than one number that makes it undefined. And so I think the best way to approach this is to kind of start by just testing out some numbers and figuring out, a pattern of like what types of numbers, do make this defined, which types of numbers don't make it defined. And so what are we going to be on the lookout for? Like what will make this undefined in general is if the stuff under the square root is negative. And by the way, there's a word for that. The stuff under a square root is called the radicand. So this will be undefined when the radicand, the stuff under the square root, is negative. And let me just define radicand here. So the radicand just means the stuff, super technical word here, under the square root. And by the way, it's okay for the stuff under the square root to be 0. So there's nothing wrong with taking the square root of 0. The square root of 0 is equal to 0, right? Because square root of 0 is asking you what number would you have to square to get 0, and the answer is just 0. The problem is when it's a negative number. So what I want to do, as I just said, is I want to first start by finding, let's do 3 numbers that are in the domain of this function. So basically 3 numbers that you can plug into this function. So we're basically looking for numbers that when we plug them in, we get something positive or possibly 0. So one number that would work would be 3, right? We just talked about it. If you plug in 3, you get the square root of 3 minus 3, which is the square root of 0, which is 0. So that is fine. That is defined. So what about if we plug in, let's say, 4? So there we'd have the square root of 4 minus 3, so that's the square root of 1. That's equal to 1, and that is fine. We have a positive number under the square root, so we're able to actually take the square root. Now let's maybe continue in that direction and try plugging in 5. So if we plug in 5, we get the square root of 5 minus 3, and that's the square root of 2. That one cannot be reduced because 2 is not a perfect square, but it's still okay, right? We're not trying to take the square root of a negative number, so we're okay. So the 3 numbers that we just figured out were 3, 4, and 5. And by the way, if you were doing this yourself, you could totally try numbers and find out that they're not. I kind of picked numbers that I knew were in the domain, but if you just picked a random number, it might not have been the domain, and that's okay. You could then kind of answer that in this next part. So now let's find 3 numbers that are not in the domain. So now we're looking for numbers that actually make the radicand negative. So maybe let's actually take a look at what happened when we were plugging these 3 numbers in. So why was it that we got things that were okay? It's because the number that we were plugging in was big enough that when we subtracted 3 from it, we still got something positive. So what could we do that would kind of turn that around and give us something undefined instead? Well, if we plug in a number for x that is less than 3, then we're going to start getting negative results, right? So if we do, for example, h of 1, we would get the square root of 1 minus 3, which is the square root of negative 2, and that is undefined. Let's inch up a little bit more. What if we try h of 2? Well, we get the square root of 2 minus 3, which is the square root of negative 1, which again is undefined. So we found so far 2 numbers that are not in the domain. So how would we find another number that's not in the domain? Well, we saw that 3 is in the domain, right? So 3 isn't going to work. We could try something with decimals or fractions, or if we want to do another like whole number, we need to go in the other direction. So for example, if we plug in 0, we would get the square root of 0 minus 3, which is the square root of negative 3, which is also undefined. And so the 3 numbers we found that are not in the domain are 0, 1, and 2. Okay, so the last thing I want to answer, now that we've kind of played around and gotten a sense of what numbers do and don't work, I want to use those ideas or use those kind of findings to describe the domain. Okay, so what did we find? We basically figured out that if the number we're plugging in for x, so maybe let me go back up to our original function if my screen doesn't stick. So if the number you're plugging in for x is bigger than 3, things are going to be okay, right? Because then when you subtract 3, you'll get a positive number. The problem arises when the number you're plugging in is smaller than 3. And so what is the domain? The domain is going to be all real numbers that are greater than or equal to 3, right? Because we saw that it's okay to plug in 3. That gives you square root of 0. That's fine. It's when you get a number that is less than 3 that things go awry. So we need to make sure that we're plugging in numbers that are greater than or equal to 3, and so that's our domain. Again, in the next video, we'll learn a way that will make this process a little bit smoother, but I really do think that this kind of trial and error part is an important way for you to get a better sense of how these things work. So I really encourage you, even if maybe you've learned like a more kind of a faster way of doing this, I really think the trial and error part is an important part of like the kind of understanding process of this. Okay, so let's say now that we have a function k of x is equal to the square root of 8 minus 2x. So again, I want to kind of go through and find numbers that are and are not in the domain. Maybe let's just do 2 of each this time. So the first thing I want to do is find 2 numbers that are in the domain of k of x. So that means we want to find numbers that when we plug them in, we get a positive number under the square root. So of course, you can just start this by just trying random numbers, right? You could try 0 or 1 or 2 or 3, whatever you want to try. But kind of looking at what's going on here, we can see that we need to make sure that whatever 2x is needs to be less than 8, right? Because we're doing 8 minus 2x. And so if 2x ends up being bigger than 8, that means that we're going to end up with 8 minus a bigger number, which will give us a negative under the square root. So what would be an example of a number we could plug in that would guarantee that 2x would be smaller than 8? Well, we could plug in 1, right? If we plug in 1, we would get the square root of 8 minus 2 times 1. And so that's going to be equal to the square root of 6, and that is just fine. Square root of a positive number is okay. Now let's maybe think of what's the very biggest number. Let's kind of push this to its limit. What's the biggest possible number we could plug in for x that is going to make this work? Well, remember, we said that we wanted to make sure that 2x is less than 8. Really, actually, it can be less than or equal to 8, right? If we can get 2x to be equal to 8, then we'll get a 0 under the square root. So what would make 2x equal 8? Well, that would be if we plugged in 4, right? So if we plug in 4, we'll get the square root of 8 minus 2 times 4, and that's the square root of 0. And that is just fine. That is equal to 0. So basically, the trend you might notice is that if 4 is the very biggest number we can plug in, we can basically plug in any number that is less than or equal to 4, right? As long as you're plugging in a number that's less than or equal to 4, you're going to get a result that is positive. Even if you plug in a negative number. So maybe we don't really need to do this because we already found 2, but maybe let's just briefly see what happens if we plug in a negative number. Like let's say we plug in -1. So if we plug in -1, we would get the square root of 8 minus 2 times -1. And so what would happen is that 2 times -1 is -2. And so then you're subtracting a negative. And so you would get the square root of 10 because you'd have 8 plus 2. So it's okay to plug in negative numbers. That's still going to work out. Okay, so let's now find 2 numbers that are not in the domain. And I should have said this earlier, but as always, I'd encourage you to pause this and try to come up with them yourself. 2 numbers not in the domain. Okay, so now we're looking for numbers that when we plug them in, we get something negative under the square root. So we already kind of talked about this, but we want to just basically make 2x bigger than 8, because if 2x is bigger than 8, we'll get a negative when we subtract it. So one way we could do that is by plugging in 5, right? K of 5 would give us the square root of 8 minus 2 times 5. And that is equal to the square root of 8 minus 10, which is the square root of -2, and that is undefined. So continuing in that direction, if we do anything else like bigger, like we could do 6, you could do 5.1 or 5.5 or anything that is basically bigger than 4 is going to work. But just for the sake of doing like a whole number, let's say 6. So we'd have 8 minus 2 times 6. And so now that is 8 minus 12. So that's the square root of negative 4. Again, that is undefined. And so our answer for this first one, we said that 1 and 4 were two numbers that were in the domain. And then we said that 5 and 6 were two numbers that were not in the domain. Okay, so now we can describe the domain kind of based on our findings here. So basically going back to what we said in the first part, we said that any number that is less than or equal to 4 is going to work, right? Because that's going to guarantee that you get something positive. So the domain is all real numbers less than or equal to 4. And so what I wanted to point out, the reason that, we did these two examples that maybe seemed kind of similar, notice that on the first one, our domain involved the word greater than or equal to. Whereas in this one, the domain involved the word less than or equal to. And the difference was that in one of them, we were doing 8 minus 2x, so we were subtracting x from something, whereas in this one, it was in the opposite order, as x minus 3. So things kind of play out differently depending on exactly what is inside your square root. Right, one more example that was going to be the last example in this video. So we've seen basically that the reasons that things go bad in functions is because of dividing by 0 or taking the square root of a negative number. So what about if you have a function that does not involve either of those things? So let's say we have the function, so let me say, describe the domain of the function f of x is equal to 5 halves x squared minus 3x plus the square root of 5. Okay, so we want to be looking out for, are there going to be any situations that will involve dividing by 0 or a negative inside the square root? And so your eye might go to, okay, we do have a fraction, we do have a square root in this function, but the difference is that this fraction does not have any variables in the denominator, right? It just says 5 halves. That's just a number. There's no variable that could possibly kind of make the denominator 0. And then similarly here, this is just square root of 5. That's just a number. There's no x inside the square root to kind of give any variety to what is going to be the result of that square root. And so basically, because there are no variables in the denominator and there are no variables inside a square root, nothing can really go wrong. So because, let me use a different color. Because there are no variables in the, or I'll just say in denominators or square roots, nothing can go wrong here. Like nothing is going to make this undefined. And so if nothing can go wrong, what does that tell you about what you're allowed to plug in? It tells you can plug in any real number you want. So that means that the domain is all real numbers. So that's going to be the case for any function that is what's called a polynomial. I'm not going to write that down because we haven't defined what that means yet. But basically any function where all you're doing is kind of raising x to different powers or multiplying it with different numbers, because there's no division by x and because x is not within a square root, there just isn't any situation that will give us something undefined. And so therefore the domain is all real numbers. So, make sure I think it's one mistake students could make on this is just kind of looking at these fractions and square roots and kind of letting that trick you into thinking there's an issue when there really isn't. All right, so that is it for this video. So as always, please take a look at the worksheet for this video. And as I said, in the next couple videos, we'll make this idea of finding the domain a little bit more precise and kind of learn an algebraic process that you can use to find the domain rather than just testing out numbers. So I'll see you all in the next video.